Hey everyone, hopefully you're here to watch the NSX Advanced Load Balancer lab with AMKO and Kubernetes. I'm Nick Robbins, I'm one of the product managers from the Avi group, and I got Brandon Anderson here with me, who is one of our field engineers.
Hello.
We're going to go through just a quick little discussion, some marketing stuff about Avi, how Avi works, how we built the lab, and then we'll kind of get into the lab content itself. Our nerd pictures. Notice that the beard matches. All right. Marketing slides. Let's build this thing out. All right, so first, how many of you guys are network load balancer guys? And how many of you guys are like hardcore Kubernetes guys? Okay, that's good, because then you guys won't be able to catch my mistakes as easily. I'm a network guy and not a Kubernetes guy, so I know enough Kubernetes to be able to build a lab out of it, but I wouldn't put my stuff in production. So a bit about Avi. Hopefully you know that we're a load balancer. We're a software load balancer, which gives us a little bit of flexibility compared to the old model of one on box and one off box, as far as where you can put us in the network and what environments we're deployed in. Since we're software, you can deploy Avi controllers in certain locations, and you can have it manage service engines in different locations, different environments, different ecosystems. Supporting bare metal, virtualized, and containers. So the container pieces, we don't put the service engines in containers anymore, and we'll talk about that in a second as a history lesson. But basically, you could take an Avi controller and deploy that thing in AWS or vSphere and control the service engine VMs in NSX or in bare metal or in OpenStack or in GCP. Basically, you do not need to have them in the same environment. So you heard me talk about controller and service engine. That's control plane and data plane. The control plane you would host the configuration UI, you do all the configuration through there, API endpoints, and would do all of the log collection and analytics stuff inside the controller, where the service engine does the work. So when a service engine comes up, it has a zero configuration. It's just a dumb VM with nothing going on, and then the controller pushes configuration to it to teach it what it needs to do. So if you're talking the cattle versus pets model, all of our service engines are cows. We shoot them on a regular basis here. So they'll get weird names. You won't ever have to do you shouldn't have to do any direct troubleshooting on them unless things have gone very badly for you. And hopefully they're just an afterthought. So being a proxy right in the middle of all of the traffic streams gives us the ability to do analytics on all that traffic, and it's almost like a constantly running TCP dump. So we can save the logs, index the logs, show you what's wrong with them, show you connections that are long-lived, all these things that are enabled by being a man in the middle. Very handy stuff if you come from a legacy load balancer world where maybe there aren't any graphs and you're kind of in the dark. And we will show that in just a little bit. The controller, like I said, acts as an API gateway or API endpoint for all the configuration. We are API first, so anything you do in the UI or CLI can be done in the API. I don't think that there's hidden stuff that can't be done in there. When the UI and CLI do something, they are making the API call, and you can watch it happen in developer tools or some commands in the shell to show that stuff, which makes it easy to automate. And then the SDNE parts, elasticity, so the controller in most deployments, the controller runs the lifecycle of the service engine. So if you need more load balancing capacity, or if a service engine dies, it's the controller's job to spin up a new one. And it does that by interfacing with your ecosystem, be it NSX, VMware, AWS, whatever. It talks to those endpoints and tells it to spin up a new VM, deploys an OVA, whatever, and it can do all that stuff on demand. And it gives you active high availability. So you don't need to have the one box sitting there cold waiting for traffic to happen, and all it's doing is burning electricity and spending license dollars. You can actually have all of your little worker bees doing something, which is the resilience piece. So if one of those active service engine dies, obviously there's enough capacity. We run the elasticity thing, spin it up, and everything's all good. I think the marketing guys call it self-healing. All right, so at the end of the day, we're a load balancer, so the most important thing is load balancing, which is local traffic management. Also have GSLB features in there if you need to try to load balance data centers. Hopefully everyone knows GSLB is just fancy DNS. have an application security portfolio. It's not just WAF. It is a variety of different services inside Avi which enable security, which would be, you can do network security policies based on IP reputation. You can do DDoS rate limiters and stuff to try and keep some of that traffic out. We're not a volumetric DDoS. You probably wouldn't want to spend the Avi money to do that because you'd have a lot of hardware sitting there doing nothing if you were waiting for an attack like that all the time. We have a web application firewall for you to, kind of block out most of the common CRS rules, the OWASP top 10 rules, and different learning mode stuff that you can do in there to try and do a positive security where all traffic is blocked by default and only the good stuff is allowed. We help you out with that by a learning mode where we can watch traffic, and as the traffic comes in, we can use machine learning to identify what's good and what's bad, because if you ask an application developer who should know, he doesn't know, and he will never give you the straight answer on what the correct application parameters are. And then the one you're most worried about, Container Ingress Services. So back in the day, when I was a customer, they had this cool thing called Kubernetes, and Avi would inject a service engine right onto your Kubernetes cluster, and it was awesome. You had full tenancy based on the namespaces. There was you can handle east-west load balancing, all of that stuff right inside of there. But in order to enable all of that cool east-west microservice stuff, you had to have a service engine on every single Kubernetes node, and you ran into scale issues because service engines in Avi can, as soon as they need enough performance capacity, you have to increase the size. So we stopped doing that super cool thing, and now we do AMKO, and that's what this lab is all about. And we will talk about, hopefully in depth, after these intro slides. So I already talked about orchestration, elasticity, resilience, automation. The last one on there is our cloud services. Up until a few weeks ago, it was called Pulse. Apparently, the marketing team has not updated their slides, so now it's called Cloud Console. And that's like a value-add set of SaaS services that we provide customers who buy the cloud license, which is the same price as, maybe even cheaper than the on-prem license. And it enables centralized license management so that instead of having an individual license file on every controller, you can have a pool of licenses. And then that way you don't need to buy that cold site. So say you're doing a DR scenario, you got one site sitting there waiting to take the load, burning licenses. With the centralized license model, once that first one dies, it's going to turn its licenses back in, and then the new one can spin up using those original licenses. You don't need to buy duplicate licenses anymore. Also around the security stuff, everybody knows that things like IP reputation databases change hourly, so the only possible way to keep those rules current and accurate is to have a cloud service where you can download them from the internet. So IP reputation databases, GeoDB databases for cloud provider subnets, and then application rules all come from there to enable our bot detection features and stuff like that. Constructing the lab. There's never enough time in the development cycle to do this. This lab is extremely automated. We kind of push the envelope a little bit as far as automation inside of a hands-on lab. Typically, those were built in the past in a few months as a static pod and then never to be changed again. Mine changes every time it starts. Usually I miss a detail and need to fix something, so I have to go in there and fix it in a Git repo, and then the next lab that gets built will get that new stuff. Everything's all good, hopefully. New this year, the very first year we based this lab on NSXT, but we didn't have an NSXT cloud connector yet, so we didn't get to show it. Then we switched back to vSphere because of size constraints. Pull those giant NSX managers out of there, gives us a little more wiggle room in the pod. Now everybody's pod is huge, so I don't feel like an outlier. NSXT's back in. I can show the integration with NSXT, and everything's all good there. Also, we just released, again with this whole dynamic lab thing, a new feature came out in AMKO that happened after I made the first version of the lab for layer 4 CRDs to be able to adjust layer 4 virtual services. So we can show that in this lab now as well. Any questions so far? I feel like I'm blasting through words at a very rapid pace here. All right. So we try to get the ideas from the sales team. I don't know if I said that or not. A quick architecture diagram. Everybody likes diagrams. So lab, it's a 2-site lab because we want GSLB to work, which is the AMKO part of this. We've got Avi controllers in each site. We got vCenter servers and NSX managers in both sites, and then ESX servers. These all run Kubernetes. I'm running kubeadm. If I put Tanzu in here, I would definitely be on the large lab violator list. So that's why it's kubeadm clusters. It's also easier for a guy who is not a Kubernetes expert to manage, because sometimes you get into the Tanzu weeds and there's a lot of letters after it and nobody really knows what version it is, at least if you're not in that world. That's what it seems like to me as the network guy. So we've got a handful of different services running on node ports, which we'll talk about later, and then we have the console that you're seeing on the screen is a Linux VM doing a lot of the automation and stuff. What are you going to learn? So I'll show you a little bit about Avi. It's not going to be super Kubernetes-centric. I'll talk a little bit about the differences in cloud connectors, how pools and applications work. And then after that, we will get into AKO and what AKO brings to the table. We'll deploy it, which should hopefully be an easy thing and nobody's lab will explode. Then we'll talk about the advanced features, which is going to get into how virtual services get spread across the different child virtual services in the lab. CRDs for how to adjust parameters after the fact, so there's a certain way a virtual service will get created based on the Kubernetes service, and maybe you need to change things like a different certificate or a different SSL cipher or something like that. The CRDs will help you modify that configuration. And then GSLB, how do I take Kubernetes applications at different data centers and make them look like one FQDN? And then a quick overview of node port local, which is going to be talked about in depth later, I hope. And of course, it's going to be totally authoritative talk, too. All right, we're going to follow the 2437-04, which is this lab's content. You don't need to be a Kubernetes expert. Hopefully you have a little basic knowledge of it and a little basic knowledge of Avi. There's a lot of content here. We'll talk about the architecture. I think I mentioned these things already. If there are any other Avi topics you want to explore, we probably have a lab for it. Got quite a few labs all based on the same architecture, so the scripts inside will help you, I guess, convert the lab to whatever scenario you need to do the lab for. So take some of the other ones if you want, and take the survey when you're done, not now. All right. So everybody's logged in but hasn't started yet. Let's go ahead and start the lab. Give everybody a few seconds and hopefully we see a lot of green reddies out there. The first thing we're going to need to do on this lab in order to kick everything off and make sure stuff builds is click this module switcher thingy. Click this AKO line so it turns dark. Hit go to module selection. Click this first button over here, module 1, and let her rip. Is it fine now? Better? Not popping? Okay, cool. Yeah, the mics are a constant issue up here. All right, so what this is doing is this is basically configuring most of the secondary site. We're going to cover the primary site during this stuff, but once we get to the global stuff, and to save you the time, all of the Site B stuff will be set up already, and then hopefully everything works. So hopefully you get to this point, you should see failed equals 0. At least one guy got failed equals 0, so we're on a roll here. So about the interface, we'll probably be making use of this table of contents quite a bit to kind of explain where we're at. Infrastructure review of how to work. Okay, so we talked all about this infrastructure stuff, our architectural stuff already. And then we'll move into creating a virtual service. So virtual services are the meat and potatoes of Avi. That's the whole reason we exist. And so this is happening because we're waiting. The reason this is red is because we're waiting for service engines to be built. That takes a couple minutes. There wasn't one there before. We're on pretty tight lab hardware. We have to wait for an OVA to deploy, for it to boot up, and then ask the Avi controller for configuration information. So that takes a minute in this lab, but it's not going to bother us right now. You can see these other ones we have are already online. So what we got here is 3 different virtual services. One that's just a demo one that has traffic hitting it, so I can show analytics. A DNS virtual service, which is acting as a DNS listener for our environment. We've delegated an entire domain for this region that is sent, so there's a bind server running at the top. It delegates a subdomain to Avi, and then Avi responds with all the DNS records for that. And that's so we can create a virtual service and automatically assign an FQDN and a DNS and IP. Just a second. So in case you guys missed that, after the module switcher scripting runs, just go ahead and open up Firefox, and then in the region A bookmark folder, there will be NSX ALB controller limits. I'll just show you. Click that guy, and then that'll bring you to the screen I'm at. So where was I? DNS listeners. So the one we're waiting on, or the one that is spinning up on the background that we won't get to right away, is the global DNS. Best practice is to have local DNS listening on one listener and then your GSLB DNS listening on another listener, and that has to do with the way health checks and stuff work. So that's why we're spinning up another one of those. So we go in here, let's switch this dashboard. One of the things we'll be showing later is tree view, so let's just prep that. This kind of shows us the way the application works. We see we got our virtual service here. It's pointed to this pool, which has these members, and it's deployed on this service engine. So it's kind of a quick way to kind of see what's going on with this specific guy. And then we'll go in here and look at this configuration a little bit. Actually, let's make one. I think I have you make one in the lab. So we're going to be on manual page. Start on manual page 26. It's going to show you a basic wizard one. We'll step through that real quick, and then I'll do an advanced one and talk through some of the more advanced features. So go back to the beginning here, click this blue button. I clicked virtual services on the left, which brings you here, then the blue button, and then go to basic setup. And then it's going to ask you cloud. So Avi has something called a cloud connector inside, which is effectively the driver that tells Avi how to talk to the backend infrastructure for service engine deployment. In this lab, we're using the NSX cloud connector. So we're going to talk to a combination of vSphere and NSX, vCenter server and NSX manager, in order to configure some basic networking stuff through NSX and then deploy the OVA through vCenter. So we're going to pick this site A, NSX Cloud. And then what it's going to do for the T1 is create a separate VRF. It does this automatically. Typically, if you deploy an Avi configuration stock, you're just going to work with global. But the way this NSX connector works is it's going to make a separate VRF. So we're going to say we want to be in that one. And then now we get into the typing. This is the basic virtual service. And unless you took the O1 lab earlier, the basic wizard, I'm sorry. Unless you took the O1 lab earlier, this is probably the only time you'll ever use this thing. It exposes very few of the features in Avi. It's just a quick way to get going. So we're just going to do a basic HTTP type wizard. We can call it basic app A. You can call it whatever you want, really, but basic app A is what's in the manual. We're going to come into this screen. You see we got the green create VSVIP button. Hit that thing. You'll see it pre-populated the name and appended a VSVIP on it. A VSVIP is a separate object in the object model that is just the IP. So the virtual service is the port. The VSVIP is the IP. And then together they would form the application. You're going to need to select your T1 logical router here. So click that T1 or T1 GW site A thing. Then you're going to add a VIP to it. Some of the stuff in the cloud connector for an automation perspective is an IPAM and DNS profile. So we work with different IPAM providers. We can provide Avi IPAM directly. where you set up a network and you say the range of IPs that I want to deploy to either service engines or VIPs. We can work with info blocks, connect to info blocks. It will request the IP or the DNS name, and then things like Route 53 or the cloud-specific IPAMs, like AWS doesn't let you run your own IPAM because they want to manage the IP addresses, so we have to be able to talk to them to request that. And that all gets set up in that cloud connector, and then once it's set up in the cloud connector, you're going to get cool drop-down boxes in here where you say auto-allocate. Okay, this looks like the only network I can choose from. I'm going to park my VIP in this subnet, hit save. And then you want to add an FQDN, so it's going to auto-populate what you already did for the name of the virtual service. You could change this here if you wanted. TTL, all the basic DNS stuff. Just hit save. Should have added one, and then hit save again. That should have made you a VS VIP, and hopefully you did an error, and now we can scroll down a little bit to the add servers part. So the server we're going to use in this case is 172.16.110.10. We hit add server, boop, and it goes down here into this list. Now, since this is the basic wizard, you only get asked for this port number once. It's going to use this port number for the front and the back. You're probably not going to do that all the time in production because maybe you want 443 on the front and 80 in the back, or you got some totally different weird port in the back, like you'll really experience in this lab. There's going to be ports all over the place in a Kubernetes lab. That's the way they roll. So the basic wizard isn't going to work to deploy those virtuals anyway. But anyway, the point is that the front end port is going to be the same as the back end port when using the basic wizard. So we got our port, we got our server, we hit save, and then hopefully we'll hover over that and it turns green there, and you should be able to go into your browser. And we have a running web server. So fast to make a VIP in Avi. But there are 8 billion different features that you can do to adjust the behavior of this. But I'll give you a minute to play through that basic one and oops. Good on that basic one? All right. Now I have to bury you with complexity. So if you were to bring up the advanced wizard, you'd get something that looks more like this. And just a quick note about the UI differences. This is what would be the original Avi UI, and all those really long blue pages are the new Avi UI. And that's because we switched to a VMware standard UI framework that's newer. It makes things longer instead of wider. It can be a little weird, but we haven't gotten everything migrated yet, and this is one of the last ones because it's the most complex wizard we have. So it's taking longer to get there, but we would hope to have that done pretty soon here. So name and VS VIP, those are obviously the same. You've got traffic enabled and enabled. Enabled is the on-off switch, and traffic enabled is whether or not we're going to respond to the ARP request. So that can be handy where if you've got your old load balancer over here serving the traffic, you built an Avi over here, you give it the same IP address, you turn it off here, you flick traffic enabled on there, you can test and make sure all that stuff is working correctly before you fully fail over. Application profiles in TCP, or now this is, I don't know why they call it a TCP UDP profile. It's really called a network profile in the API. So this is the fast path versus you're not going to see it there. It's fast path versus proxy. So, and then UDP. So application profile kind of dictates whether or not it's going to be a layer 4 or a layer 7, and then system secure HTTP would be a bunch of security flags enabled by default versus being turned off in the HTTP one. We're actually going to create all three of these things as part of the AMKO services. A lot of different things you can do in policies. So it's If you guys are having problems seeing all of this in the screen, you can zoom out to about 80, and then it will look a little better. And that's dependent on whether or not you need glasses like I do, but you should be able to see it on the Pier 2. All right, so this application profile, a lot of the HTTP level settings, this is a layer 7 one, obviously. Connection multiplexing, kind of some standard stuff in here, WebSockets, chunk merging. But where you get down into the meat of this is the security stuff. So a system secure HTTP one would have all this stuff checked by default, where a just system HTTP does not. Most of these things are good things that you're going to want to do. This last one, HSTS, can sometimes break your app, so you want to make sure you test before you blanket apply that. It doesn't mean it's a bad thing, it's just that most people don't set up their web servers to handle this stuff correctly, so then you end up in that state. Client certificate if you need to be able to do mutual auth or anything like that. Compression, caching, some pretty standard load balancing stuff. These were the DDoS rate limiters I talked about as part of the security profile. There are some sane defaults already set, but this is to kind of like, make sure that the you don't get blown out of the water by like a very large header attack or anything like that. Set a limit on how big the headers can be, and then you should stay relatively safe. Some things cannot be configured in here, like sin cookies attacks. That's just always on. But that's so fancy rate limiters and stuff. You can do additional rate limiters on the actual TCP requests per second, packets per second, things like that. So that's application services. You can also enable WAF policies and bot detection policies. WAF policies are something that you'll do with a CRD in this lab. You wouldn't configure it in here. Pretty much anything in here you're not going to configure. You would, if you're doing the AKO deployments, because you'll do all of that in Kubernetes, because that's kind of the point of the Kubernetes thing is to handle it all from there. That's going to be your management plane. Setting the port and the pool, which we've already done. Policies are extremely powerful. This is where we try to simplify the iRule deployment of F5. So F5's got lots and lots of iRules to do lots of things. We try to get most of their iRules, 70 or 80% of their iRule scenarios baked in as policies, so that you can do it with drop-downs and checky boxes. You've got layer 3-4 ones at the security layer, and then you can get up to layer 7 ones at HTTP security, and then do some request stuff. So basically that looks like this. Let's add a rule, and you guys don't need to do this right now. You can just follow along. So you can see that we match on all the layer 7 type stuff, like path and version. If you needed to do an HTTP to HTTPS redirect, this is one of the 3 ways you can do it, is you go in here and say, if it's HTTP request, send it to HTTPS by saying redirect like that. So you've got the different match options, and then you've got the different action options that you can use. Request policies are less about security and more about how to modify the request. If you need to do a content switch, say you've got pools just for static file uploads or something like that, and you want to switch based on a URI, this is where you would do it. You get kind of the same match criteria, but you get a different set of actions here that are more application-centric. And then response headers, if you need to drop a header or to rewrite a location header or something on the reply traffic, that's where you do that. And then access. So access is if you have an application that doesn't have an authentication mechanism, but you do want to have authentication. For instance, you built a home web server to do some stuff, but you don't want all the internet people to get to it. You can throw authentication layer on through this, where we would support a SAML or an LDAP authentication backend. You can also add in two-factor auth and things like that. That is newly supported in this version of AKO that we have in this lab as an SSO rule CRD, so that you can take a Kubernetes app, stick two-factor on it by having Avi do all that work. We're not going to do that because I don't have a Workspace ONE server in my pod, but maybe someday. Oops. Analytics. Analytics is the bread and butter of Avi. If you've worked with other load balancers, you would know that sometimes that is lacking. We have pretty manager-approved graphs that will show you timing, throughput, connections per second, things like that. On a 5-minute interval. If you need to go 30-minute interval for metrics, I think it's 30-minute for metrics. All right, you've caught me on my first broken bat thing. Anyway, normally we would gather these metrics relatively slowly. If you need to do troubleshooting, we can enable something called real-time metrics. It'll pull them every 5 seconds. That one I do know. All right. So analytics, requests per second, pretty standard graphing stuff, and then you get into the logging. So we've got a traffic generator hitting this server, and we're measuring. So I'm trying to pull a whole day's worth of data. I need to only pull 15 minutes, and then maybe I can get it to speed up. Huzzah. So we've got two log concepts, non-significant and significant. Non-significant logs are 200s and 300s that have not exceeded a threshold. This should be the majority of your traffic. Normally these would be off. When you spin up a new virtual service, they're on for 30 minutes and then will auto shut off. If you need to do troubleshooting in the future, you can turn them back on. We don't recommend leaving them on all the time for all your virtual services. You'll murder your controller. I have personally murdered several controllers with this method. So don't leave them on all the time. If you click them on, you can see you'll get your graphs will fill in real slowly here, and it'll be more greens than oranges. And significance, of course, are going to be the 400s, the 500s, and the things that exceeded some level. So these are all appear to be 404s, which is kind of lame. I don't think I'm going to be able to drag it down anymore. All right, so if you go in here and you kind of look, you can see there's quite a bit of information we've put in this in this log. We know the location of the IP using geolookup. We know the operating system in the browser based on user agent header. We know the encryption algorithms, obviously, because of it being an SSL thing. IDs and the significance. Okay, so this one ended with a 404 because the file obviously wasn't there. And then we know the front end and the back end. It came in on this IP. It was, where did it go? Yeah, there we go. Came in on this IP to this IP, and then this service engine's data NIC, this is what it was NATed to. Brendan. It was NATed to, and then this is the server it went to, the backend pool member it went to. So quite a bit of information in these logs that you can get without having to do anything special. It should kind of ease the way with troubleshooting. And then you can do analytics on those logs over here, where you can see, okay, what servers are having the 404s? It's these two servers, they're probably both missing the file. We've got a sales demo where I'll have one in there that does have the file, and then it will not show up on this list, and you automatically know which ones are broken. You know, kind of cool things you can do with analytics like that, and response times and stuff. So that's a bit about analytics. Probably the #1 Flash feature that you would want Avi for is analytics. So definitely make use of it. All right. Now that I've stood up here and talked for 30 minutes, let's actually talk about Kubernetes. So, as I mentioned earlier in the history lesson, AMKO is the new way to scale a build. Do you have a problem?
It was just really, really fuzzy.
Is it better now?
Yeah.
I must have just moved wrong. All right, so AMKO is a pod that lives inside of the Kubernetes cluster, and its job is to monitor the Kubernetes API for when new services are created using kubectl or through API or whatever. And then when it sees a new service come online, it reads through that service to see what the port numbers are, the backend servers are using node selectors, or port selectors, sorry. And then it will talk to the Avi API endpoint and say, hey, I need to make this virtual service on this, and this, pointing to these guys, and then the virtual service comes up automatically. So you don't need to create the app. It all happens as soon as the dude deploys the Kubernetes YAML file using whatever mechanism you're deploying, if you use kubectl or whatever. So as soon as it gets created in Kubernetes, it gets created in Avi, and that's what the job of AMKO is to watch for those things and then send those API calls to Avi to have that happen. So yeah, ingress controller, Avi configuration, blah, blah, blah. We talked about all this. Translate the objects in Kubernetes over to Avi objects. We would also support OpenShift routes. So support ingresses, OpenShift routes, and then layer 4 load balancer services. And then, of course, the CRDs in order to manipulate all that configuration. I think my notes are more concise on this. All right, so when you're setting up Kubernetes services, there's different ways to expose those services to the outside world. The ones you'll hear about are cluster IP, node port, and then in Antria, we have a new fancy one called node port local. We'll talk very briefly about the differences between those. Basically, cluster IP is usually going to be non-routable subnets that live in an overlay inside the pod based on whatever CNI you're using to deploy. Some CNIs will expose them as routable subnets, like the AWS one and I think the NSX one. Most of the ones you run into, if you're going to do like a Kubi ADM or something like that's going to be a flannel that will not expose them. These are things you need to tell AKO, so AKO knows what to do in the case of these cluster IPs, but for the most part, the cluster IP ranges are going to be hidden from the rest of the network. And that's going to be the way the Site A cluster is set up in this scenario, and we'll show you a bit about how we work around that. So when you go into your values YAML, which we'll go in detail in a minute, there will be a line item where you'll say my node types are cluster IP, and then what Avi will do is it is going to interrogate all of the pod CIDRs for all of the different nodes in that Kubernetes cluster, and it's going to map a static route to all of them. So it'll say, okay, this /24 belongs on this node, make a route. This /24 belongs on this node, make a route. That way, when we start putting pool member IPs in there that are in those private networks, the Avi service engines know how to get to them. In this particular lab, since we're running NSXT, there's a router above us. Cluster IP is not something you would normally use in NSXT. It only works when the service engines are in the same segment as the backend servers. They are in this lab, but we're going to try and enhance that capability in the future so that we can take those routes and inject those into NSXT. Stuff we're kind of trying to figure out how we would do. But the moral of the story is if you're using NSXT Cloud, you have to have everything in the same segment. Normally, if you're going to use cluster IP, it would be easier for you to do something like a vCenter Cloud where we don't care about it as much. And then the other way would be node port. When you do a node port exposed service, what it's going to do is kubeproxy is going to map a port on the host server to the backend pod, and it's going to do that on every single host that's in the Kubernetes cluster. This runs into scale limitations because even if the pod doesn't live on that host, there's still a port there. And then the traffic can come in on any of those various hosts, and it will go over the overlay to the backend network. And yeah, obvious issues there. And then node port local is the new way enabled by Antria, where we'll bypass the kubeproxy. It makes an IP tables tweak. The port will only be exposed on the node where the pod lives, and it will go directly to it. There's no overlay transit or anything else happening there. And then you won't have all the extra ports burned on servers that aren't hosting that pod. So it's a scalability enhancement. We'll talk about some more in the last chapter, if we get there. All right. So let's fire this thing up so we can talk through that values.yaml. So in the table of contents, whoops, I had it open and I closed it. Any questions so far? All right. So we're not going to run the module switcher anymore because you only need to do that once. We're going to go in here and look at the AKO configuration file. So minimize that. You can, you can just click on the HOL user folder at the top and then click on this HOL folder. Oh, I'm sorry, I did that wrong. I'm supposed to have you go into Visual Studio Code. You didn't catch me. And in here, you'll have the 2x3704 lab as a shortcut. We'll just go into Site A, click AKO, and then click the values.yaml. This is what's going to be the configuration information for AKO that we're going to give it when we spin it up in Helm. So this is about how often we're going to pull Kubernetes objects from the API. We have to check every so often in order to be able to refresh. Also, when the AKO pod starts up, it has to pull all of them. If you have a very, very large Kubernetes environment, this can be a zillion objects, and then it takes AKO a while to process them. So we've added a feature in newer versions called AKO HA, where we'll have a standby AKO pod that has all that state information already, and it greatly increases the failover time in large environments, but we're not going to need that in this lab. So the meat of this stuff is going to be further down in here where we start talking about our environment. So since we're running an NSXT, we have to tell it what our T1 is. As you saw in the basic wizard, you have to do the same thing in the UI as well. We're going to tell it which VIP network ranges, which kind of takes the function of that IPAM stuff we were talking about before. And then down here, you're going to be talking about some of the specifics as far as the cloud name of where you want this to land, what Avi controller it needs to connect to, service type cluster IP, so it knows how to decide whether or not it's going to plumb the routes or if it's going to leave that alone. and then a little bit about shard sizes. So since Kubernetes is meant to be a very highly scalable thing, and you can have 8 bazillion virtual services, we don't have 8 bazillion IPs. So sharding is a way to take a single IP in Avi and layer lots of virtual services on it by using SNI or enhanced virtual hosting, which is a superset of SNI, and we'll talk about that later. So basically we would look at the TLS information to be able to determine which child virtual service to send that to. In the case of, we do it a little bit differently for insecure ones, and we can show that later, where obviously there's no SNI information if you're not connecting with TLS. So, and then yeah, so passwords and whatnot. All right, so now we should be able to actually deploy this thing. So we need to fire up a shell, and then you're going to want to get yourself to the deploy thing that has the command in it, because you're going to want to drag and drop it. So once you're in here, change directory, you should be able to click and drag this, but we've been having mixed results with this laptop.
You can move to page 65.
Yeah, what he said. You should be able to highlight it and drag and drop it. It's going to, oh, look, it worked. All right, so this is basically the same section you were at inside the VS Code window. We'll just switch over to site A, and then switch to AKO, and then that's where we'll do our Helm install. So we use Helm to install this. We just recently switched away from doing Helm repos to using OCI compatible charts. So it drops us down to one single command, but the command's a little gnarlier looking because it's got this URL in it. So that's why I recommend the clicky draggy method. And basically what this is saying is I want to install AKO, AKO-site A is the name that it's going to install. It's going to pull the chart from that particular URL. It's going to install that version into that namespace. It's going to make a new namespace, and it's going to use the values.yaml that we just looked at. Should be all pre-configured for you. And then we're going to drag this guy over here, hit enter, and wait for some stuff to happen. Hopefully yours says deployed. Anybody having problems with that one? The drag and drop worked? Not are having problems or aren't? All right. Anybody else having problems with that? Yes. All right. So now if you do in here and do some Kubernetes-y stuff, like you can see we got our AKO pod running. It's been up for 100 and something seconds. Everything's good. If we go back to the UI, you'll see that it's already made some stuff. These are going to be the first shards for the Kubernetes services that we're running ahead of time. This whole lab is based on Kubernetes for our app deployment, so you have something to point web traffic at. So it's replicated all of those services in here as AKO services. What was that? All right. So we go back to the dashboard, we look in tree mode. These have very gnarly names. These are UUID-based names. This happens in enhanced virtual hosting mode, not in SNI mode. In SNI mode, you'll get a fairly normal name. This is just the way engineering's done it for this one. We'll see if they enhance it in the future, but basically what it means is it's sometimes hard to figure out which application you made in Kubernetes corresponds to which virtual service. Which service does it want me to deploy? Oh yeah, let's talk about the routing. So we talked about cluster IP and how the routes get created. So if we go into infrastructure and we go into networks, wait, ref context, sorry, we moved it. If you've worked with Avi in the past, there used to be a thing for routing in here. That's all been merged underneath the VRF context part. So if we have our cloud selected, we'll see we got the T1 VRF route, and you see there's 4 static routes in here. These all correspond to my pod CIDRs. Each individual Kubernetes worker node has its own /24. And this, of course, works fine when you're in the same segment. If that thing lived in the other segment, the NSX T router, the T1 would drop it because it does not know the route. That's why we tell you to stay in the same segment. So we looked at routes. We made AKO. If you're interested in the area of the API in Kubernetes where we check that pod CIDR allocation, this is another one of those drag and drops. Post that in there, you get a little JSON output. This is where AKO looked to learn this information to make this route. Not every CNI puts it in the same place. Calico is one of those, so that is why you have to specify in the values.yaml which CNI you're using, because we need to be able to tell AKO where to gather that information. So a little bit about how that works. So you saw the pools and services. We're actually going to create our own services in a minute. Let's see if we can figure out which one of these guys it belongs to. We're going to see our IPs in here. We can go in here and do and for these cluster IP ones, these are LB service ones are layer 4. We've actually populated IPs for them. So these are service type load balancer layer 4 ones. You see we got the 172.16.110.54. That should correspond with the virtual service in here. So that's this guy here. We haven't made any ingresses yet. These are only load balancer services. So that's why you see these 2 separate ones. Now we're going to be about ready to talk about SNI versus EVH. This is where it's going to get more complicated. So differences, I have to read this from my notes because there's a lot of details here. The difference between SNI and EVH. So SNI, the way the traffic works is it comes, as a TLS connection comes in, we look at the SNI information embedded in the TLS connection in order to know which host, usually it's a host header thing, similar to a host header thing, where it needs to send the traffic. Only works for secure, so we have to do different workaround stuff for insecure, where we would make things as a pool group under the parent virtual service. So SNI is a parent-child relationship. So the TLS information host header would go to a child virtual service. The insecure one that doesn't have any TLS information will go to the parent, and it is carved out by path to particular pool groups using content switching. In enhanced virtual hosting, we don't need to rely on the TLS information. So there's a child virtual service for insecure, a child virtual service for secure, and it gives us a little bit more flexibility in some of the stuff we can do. Now, after the TLS handshake in SNI, the connection is totally passed off the child virtual service. It's not involved anymore. In EVH, that parent virtual service handles all of that low layer 3 TLS stuff, layer 3 and 4 TLS stuff. All of that stays on the parent virtual service, and only the request level stuff gets sent to the child. So in SNI, you're restricted to a single EC cert and a single RSA cert to cover all these use cases. In EVH, you can attach many certificates with different FQDNs for specific child virtual services. It also gives you the ability to attach things like WAF profiles. Normally, you would only be able to attach a WAF profile to the parent connection, and then you'd be hosed for all your children, because WAF profiles are usually only good for a single application because they're very application specific. With EVH, you would be able to apply a WAF profile per child and get that granular policies that way. Insecure children, all right, well, I followed my notes pretty good. So let's go in there and make some of these virtual services. Let's see what chapter that is. Not this one, it's in here. Ingress objects. So ingress object is the new fancy Kubernetes way for doing a layer 7 virtual service, kind of their standard method. It's part of their API. The OpenShift equivalent is a route. Um, it's not an AKO thing, it is a Kubernetes thing. The page where we're actually going to deploy this thing is going to be down here on page 92. So if you still have your shell open, you'll just back up a level and then go into Ingress. You can see we got 2 ingresses in there, one for Avi Networks and one for Juice. I believe we're going to take a look. Let's look at the Juice. Look at this in VS Code for simplicity. Not CRDs, Ingress. So the way an ingress works is you define your host by path in there. TLS defines whether or not it's a secure or insecure ingress, and then the rules on how you're going to match the backend pathing and what ports to use and stuff. So the port stuff, the ingress is going to tie itself to a service, be it cluster IP or node port. And then that's how you tell the layer 7 stuff on top of it, but it does correspond to a service, and ingress does not exist alone. So we're going to deploy that thing, I believe. TLS already said all that. Kind ingress, host FQDN. And then now we're going to apply both ingress. And I haven't completely figured out what the plural of ingress is, but I think it's ingri. So kubectl apply -f Avi. And then kubectl apply -f juice. And you can tab complete these. And when we do that, we should see more stuff happening in here. If I can arrange this stuff better. All right, so you saw some more stuff popped in as I was in here fiddling with the columns. I'm actually going to turn a couple of these off. I'm going to leave app domain name, service ports, pools. That's a little better. Come on. Whatever. All right, so we made a new shard, we made a couple new virtual services, and you can see that our app domain name, layer 4 ones are not going to have the app domain name, or layer 4 ones do have the app domain name. The ones we just created do not have an app domain name. And that's because of the way they're displayed in here. So we saw those get created, how the ingress configuration looks on the controller. You can see some of that stuff when you come into the tree view. Expand that out. You see it's pointing to the pool group, like I mentioned earlier. So the pool gets created with these 2 backend members with the ports listing on 80. These are the cluster IPs. You notice this matches with our pod CIDR. And then that's the cluster. It's going right to the pod because we're routing to it. So they look a little bit different than the node IP ones below it. So these original virtual services that are not created from AKO, these are going directly to a node port that was mapped on those. So it's a high port versus directly to the pod here, where it's the normal port that the container's listening on. Does that all make sense so far? Not butchering it too bad? All right, so we saw how it looks. We can now do curls to that thing. This is going to be another one of those drag and drops. So bring up your shell. Very gingerly drag that over. Have it not do anything. Because for some reason this shell is... My shell died. So let's try dragging that in there again to one that listens. We hit the button. We got a redirect because we tried to go to HTTP instead of HTTPS. Let's go back up. Hit that guy there. Now we should get the 200. All right. You're going to see all that stuff reflected in the logs. So once you get, if you still have all of your Firefox windows open, we're going to talk you through it all again. The trick here is going to be trying to find our specific virtual service that we just did the call to, though. So let's go in here, click the Logs tab. Not this guy. Next one. Oh, because I don't have non-significant logs turned on. Well, that's no fun. All right. So I'm not going to be able to show that log part. But we can show the request policy on the parent, which I believe is on the shard, right? So this is supposed to show the content switch thing, but I'm obviously doing the wrong thing. We know it worked in the browser. You're going to be able to go in there and you're going to be able to see where it comes in based on a URI path, and it's going to send you to the correct member of the pool group. If I can only find it in here. Hopefully you guys who are following along better can see it better than I can. There it is. So there's the policy set that gets assigned for the two different URLs that are on the same shard. So the Avi Networks load balancer one that we created plus the Juice load balancer one that we created, since they're in the same namespace and they're both layer 7 ones, they land on the same shard. We have to attach two HTTP policy sets in order to guide them to the correct backend pool members. Today you cannot see HTTP policy sets in the UI. That's only something you could see in the API, but that's something we're adding. It never used to be a common use case to attach a whole bunch of policies to specific virtual services like this, and AMKO's kind of made us have to do that. But that's kind of a little bit about how that works. And we should be able to move on to how to do CRDs. The trick is, though, going to be figure out how I know which one I'm looking at. All right. So CRDs, there's a bunch of different CRDs you can use in Avi to configure things. We've got HTTP rule, host rule, layer 4 rule, SSO rule, and Avi infra rule. And what those mean, HTTP rule is tweaking pool stuff. Think persistence profiles, health monitors, anything you would do to the backend pools in Avi. We have host rules, which is virtual service stuff. This would be tweaking ports, changing application profiles, changing network profiles, changing analytics policies, anything you would do in that virtual service page. Layer 4 rules, which would be adjusting all of those things, but for a layer 4 virtual service, not a layer 7 virtual service. SSO rule, if you have a Kubernetes backend application that doesn't have any authentication mechanisms, but you want it to have those, you can attach authentication policies in Avi where we can send your authentication request to a backend SAML server or LDAP server to do authentication for that application. Avi handles all of that. That way your backend app that doesn't know how to do that, you get a little security on there. That's something you can attach using SSO rule. And then Avi Infra, which is where if you
So you can just
where if you need to make a tweak to the infrastructure, like which VIP network a particular virtual service needs to land on, or if you need to change the service engine group of a particular Kubernetes service, that's how you do those kind of things. So we're going to show HTTP rules, host rules, and layer 4 rules in this lab. And just as long as I can show you where to see all that stuff, we'll be in good shape. So this is probably going to send us back to the shell again. But let's look at one of those in the VS Code. So you still got your window open. You can see we've got the little section of CRDs. Host rules, these are going to match based on the FQDN. It is mandatory because that's how it determines which virtual service to manipulate. This one in particular is changing the application or the SSL certificate. When you initially create a TLS virtual service, you're going to give it a Kubernetes secret certificate inside Kubernetes. This is to change one to an Avi object. So, do you need something?
No, I was just going to say, there's a few people that are getting lost trying to find some of these files. So can you show them, if you right-click on the CRD right here, and then open integrated terminal, it'll drop you right into it, and we can just all work in VS Code.
But then I have to work in VS Code. It's going to make my brain hurt. All right, so back to the CRD. We're switching SSL profile. We're switching the certificate. We've got the stuff for GSLB, but we're going to get there in the next chapter. And we're changing the application profile to system secure HTTP. We already said it was an EVH1, and we already have had our, this is our match URL. So now I think we're going to go in here and apply some of these things. Oh, you wanted me to do integrated terminal. Hopefully it should say host rule created. Now, hopefully what I can do to make this easy on myself is I can go in here and look at our event log. And it did a create update. It'd be harder to see for me. All right, so it's the 6D1. Yeah, there we go. So this guy here, if we go in and edit it, you see it switched to application profile system secure HTTP. It's got some GSLB FQDNs already, or no, these are the match URLs for the ingress. And then what was the other thing we changed? We changed application profile. We changed SSL cert. But that's going to be on the child, not the parent. Which is something you can still see in here. So talking up the analytics and the events in here, these things do diffs, and you can see what we changed. This is the particular virtual service, the parent shard, and it got changed. The SSL key and certificate got changed from this one to this one. It does stitch on the name at the end, but basically it's a big gnarly UUID. This is the quicker way that I totally should have showed you before on how to see which objects got changed. So we did a virtual service change for the parent, we did a virtual service change for the child, and we changed the HTTP policy set to redirect to one. And those are the changes that that particular CRD made. So all virtual service specific stuff. I believe now we're going to do the pool one. Yes, the pool one. So back in our virtual service, or VS Code, sorry, too many VSs. That's the HTTP rule, same match criteria, but now we're talking pool stuff. So we're changing a persistence profile, we're changing health monitors, we're changing load balancing algorithms. So if I flip back real quick to this guy, and we see we got our child here, which was the 6BD1. We're going to go back into application virtual services. Our 6BD1 is pointed to this 564. Wow, this is really when we're needing my glasses today. This 56485 pool. Go back in here and look at this pool. And if we look at the existing health monitor that's on it, it's just a TCP health monitor. We want to switch that to HTTP and ping. It's currently running, where did the load balancing algorithm go?
It's up at the top.
Up at the top?
Yep.
It's set to least connections. We're going to change it to round robin. So back in your VS integrated terminal code shell thingy, could be still. Whoop. Yeah, that's right. HTTP rule. Hit that thing, it's hit created. If we do show CRD, whoops, UBCTL, get CRDs. Oh, that's not the one I wanted. I want to do kubectl get host rule. It should show accepted, yeah. So HTTP rule and host rule should show accepted. The previous one, show CRDs, is all the CRDs installed in the system, so it doesn't give you the idea. But you want, or doesn't give you the answer. What you want to see here is accepted. And then if we go back in and look at that pool again, let's close out of this. Go back and hit it again. Load balancing algorithm round robin. Health monitor, HTTP, and ping. So you should be able to manipulate all of the different configuration parameters. We add stuff to CRDs all the time to enhance the capabilities. So this, if you're doing application management through Kubernetes, you want to do everything through Kubernetes, and this is the way to change those virtual services in there. So pretty cool so far. So we talked a little about SSO rule. This is just kind of what one looks like. The reason it's up at the top is because it's categorized as a layer 7 CRD. But basically what you're telling it is all of the SAML configuration. If you've ever done SAML in Avi, this basically is the YAML output of what the configuration would look like if you did it in UI. So we're taking that same stuff and injecting it. This is only important if you're going to use Avi to add the authentication layer like I talked about. And then that should get us down to L4 rule. Layer 4 rules do not match on paths. They only you have to add an annotation to a load balancer service or the layer 4 service in order to get CRD to apply to them. So what we have to do first, we've got some load balancing services deployed, some layer 4 services, which we showed. Let me show you again. Those are the easy ones to find, which is why I feel confident that we can show them. So you can shell over here. It's this guy here. Layer 4 load balancer. Whoops. Go back into our CRD and look at that thing. What we're going to do is patch the service file that made that virtual service with this annotation. It's going to say, I need to use this L4 rule CRD. So let's do kubectl apply -f, and I think this might bomb out, but let's see. I confused myself with that thing because of you. There we go. So what it's saying, because I told you the wrong order of operations, is that the required value is invalid because we have not applied the CRD yet, so it doesn't know how to find it. So now let's go back and do it the correct way that it would say in the manual. Made the CRD. Let's do the patch again. What? kubectl edit -f Avi networks. Ports. What's mine say? Bear with me while I figure out why my lab is broken. You caught me. I did the command wrong. And now Q, okay. And let's drag it like a good person should. There. Okay, so patched it in. You'll be able to see. Thank you for whoever fixed me. kubectl get L4 rule. Should be able to see it was accepted. Let's take a look at what we did in our L4 rule. So, whoops. Turned on full client logging. So we talked about by default, full client logging will be turned off. I do have my microphone thing turned on. Changed application profile to turn on proxy protocol. That is probably the most common reason you're going to want to use this CRD. Application servers like SMTP servers or whatnot would like to know the source that the traffic came in from. So proxy protocol is one of the ways to do that while still running in a netted environment. So we're going to switch over to the proxy protocol thing. We added our system ping health monitor and our LB algorithm round robin. And since I didn't show you the configuration before, we can just look at it in a log and saw that it actually happened. So pool config update, added the health monitor over, or we should have been there, yeah. Least connection, switched it to round robin. So the orange things are changes, greens would be net news, and reds would be removals. So remove the last modified date is basically what happened here, and then change these handful of config values. So that's kind of how the L4 CRDs work. Very similar to the L7 CRDs, but on a layer 4 virtual service. Good? So, has everybody mostly worked through that in my disjointed, don't know how to work my own product sort of way? So GSLB. GSLB is fancy DNS. So you've got data centers in different regions, but you want to get to it by the same FQDN. Like for instance, www.avi networks, you want to be able to get to there in Europe, you want to be able to get there in US. If you're in Japan, trying to get to the US server might be real slow. So you have local data centers in each spot. Stop playing with your button. So the FQDN will use geo-lookup database tables or built-in topology policy rules in order to redirect you to specific data center regions. So we want to be able to apply that same thing to Kubernetes. We said in the beginning that we built this as a Site A, Site B cluster. They're not in any way tied to each other than that upstream router that we're going to, for lack of a better term, call the internet. And we want to be able to take Kubernetes services that are deployed in each environment and bind them together with one URL at the beginning of it. So that's how that worked, or how kind of a high-level overview of how GSLB works. The way it works in Avi, we talked about in the beginning that service engine. That guy should be up by now. So he's the GSLB 01A guy. His job is he has a specific DNS region delegated to him called, I think, gslb.corp.vmbeans.com or something like that, global.corp.vmbeans.com. All of the requests for that are delegated to his IP through the bind server that's at the top. So whenever we create a global service, it's going to land in that one FQDN range, that one DNS suffix. So now we need to go and install that. It's going to be very similar to the other one. There will be a, hold on, AMKO, GSLB members file. You have to tell AMKO how to talk to all the Avi clusters and all the Kubernetes clusters in all the regions. So we basically use the kubeconfig file, but one that's merged to be able to use Site A and Site B using contexts. So we wrap that up into a base64 encoded secret inside of Kubernetes to tell AKO how to use it. And it does use GSLB-members by default. It also has its own values.yaml, slightly different. We need to be able to tell what current cluster is the leader. We say that's Site A. Here are my member clusters. This is what's going to match in the GSLB members file. Cluster context. This is the match in the GSLB file. Sorry. And then, of course, the credentials. So now let's see if we can apply that without any shenanigans here. This is going to be another one where you're going to want to drag and drop, so let me find that command. the first thing you have to do is deploy the secret, where we take that GSLB members file, do the base64 encoding, and inject it into Kubernetes. Whoops. Config secret created. So it's in the Avi system tenant, or namespace, sorry. And we should see it right in there as GSLB config secret, created 12 seconds ago. Woo! And then now we will try to do the actual deployment. You'll see this looks very similar to the Helm install we did for AMKO. Basically only changed a letter or two here to denote the different container. Let's drag that in, hit that. It's going to pull container down, deployed. All right. So the way AMKO is going to work is it's going to look for a particular annotation on that Avi service. How are we doing on time? It's going to look for an annotation on that Avi service to know whether or not we want it to be a GSLB service. And then when it does that, it will do the creation of that service. So everyone here's got their deploy done. Go CRDs into this chapter. See what page we need to be on here. So deployed similar with the this configuration is done tweaking CRDs and stuff just like all the previous ones. You can actually see that CRD in here. What folder is it in? AMKO CRD. That's easy enough. So a similar thing where we need to be able to tell it which health monitors to use, which pool algorithm to use. This is the way we edit the configuration of the global service that's made before. So we already had that annotation when we deployed it the first time, and then once we deployed AMKO, it saw that annotation and created the global service. So if you click into this guy, you can actually see that it's living already on region 01A and region 01B. Real quickly, I can go back and show you that original ingress file that did that. I thought I could. GSLB, yeah, whatever. You know what I did there. All right, so we got our GSLB site configured. We could go in here and look at it real quick before we apply the CRD. See the parameters. So the parameters we're looking to change again are HTTPS or system GSLB, HTTPS, system GSLB ping, and we're going to change the geo algorithm over to consistent hash. As it is right now is round robin. And then the health monitor is this AMKO derived one that is not an Avi system one. This is just a default that AMKO uses. So a similar thing where we're going to go in here. Close this, open this. So now we've changed to the normally named health monitors. And we've changed to geo-based load balancing. So same concept as we do with all the other virtual services, but applied to a global one. So it affects both of those children ones. Any questions on that? So just real quick toward the end here, we talked about node port local. Site B is running as a node port local configuration using Antria. So that means all of its services get exposed on individually mapped ports to pods on that host, avoiding kubeproxy just using an IP tables rule. So that helps with scalability. You don't need to follow along, I'll just show this. I've got two pool members here. if I go in here and change my UCTL config, deployment. So remember we have 3 Kubernetes nodes in our cluster. If these were exposed as node ports, there would be 3 pool members, 1 for every node. Since we're running in node port local mode, there are currently 2 because that's how many pods we have running. So we're going to scale this deployment up to 10. It says we have 10 up and available. Sometimes this magically refreshes, sometimes it doesn't. Now we have 10 sets of pool members over here. So again, node port would have been 3, regardless of how many backend pods there are. In node port local, you should have 1 mapped port per backend pod. So it helps with scalability because for a lot of these ones that only had 1 backend pod, there still would have been 3 ports mapped. You're burning ports on servers that don't need it. This burns ports only when necessary and routes directly through instead of using the overlay. Make sense? So if you guys are finishing up before you all take off your headphones and take off and start ignoring me, take the survey. And remember, there are 4 other labs to complete. Start with that getting started if you haven't had a lot of runtime with Avi. It's pretty comprehensive. And then thanks for coming.
Yep, thank you.